So the question we're going to do today is Valid Sudoku. It is question number 8 of our NeetCode playlist and question number 36 of LeetCode. The space was less here, so I wrote the question number here. So what is Sudoku? You must have heard of it. It's a famous game, but in case you haven't, Sudoku is a game in which there is a 9 by 9 grid, 9 by 9 grid, and there are 9 squares this way and so this way. So 9 rows, 9 columns, and we have to fill the full grid using numbers, but we have to keep some rules in mind while doing that. First rule is, in any row, there are 9 rows, in any row one number cannot come twice. So if this is the set, then it is not a valid Sudoku. So if 1 is here, that means in the full row there will be no 1. Second rule says, if 1 is here, that means in this, this is column, in this column, now in this row there will be no 1. That means in each row there can only be one, and in each column there can only be one. That means, like, let's say there are 3 here. That means in this row, this column, there will be only 1 3 which is here, and in this row there will be only 1 3 which is here. And also there is a third rule that says, for any element there are 9 boxes in this game. Okay, first box is this one, first box, and second box, third box, fourth and fifth and sixth and seventh and eighth and ninth. Each box contains of a 3 by 3 grid. So the third rule says, in each box one number can only come once. So that means if 3 is here, that means in these 8 cells there will be no 3, only 1 to 9 numbers except 3. And in this also, if 1 is here, that means in these 9 cells there will only be 1 here, and the other numbers will be in the different cells. And for there, let's say the 4 is here, doesn't matter 4 is where. If in this one box 4 can only come here because we have written it here. That means if 4 is here, that means these 8 elements will not be 4. So these are 3 rules that we have to keep in mind while filling the table. So the question says, we will be given a Sudoku, a partial Sudoku solved. Not all cells. Let's say, take an example. So we have 5 and then 3 and then 7, 6, 9, 8, 1, 9, 5. This is on the question on LeetCode, so I am just copying that same example. We got 8, 4, 7, 6, 4, 1, 9, 8, 8, 6, 2, 3, 8, 6, 2, 3, actually 2 and 3, and we have 6, 3, 1, 6, 3, 1, 6, and 2, 8, 5, 9, 7. So in the question we will be given a grid in which the Sudoku will be partially solved. Now we have to tell, we don't have to solve the full Sudoku, okay, we just have to tell these numbers. Right now the image we are getting, is this a valid Sudoku or not? That means, like, let's say if this 8 was here instead of here, 8 here, that means we can see that there are 2 8s in single row. That means this is false. So then we return false because this current image of the Sudoku is not valid. Like 5 is here, if there was a 5 here instead, that means same column, 2 5s, so this is also invalid. So or again, let's say there's a 9 here and then we had 9 here, that means 2 9s in single box, that means this is also not valid. So what we will do, we will do one loop across every cell of the grid. So there are 9 rows, 9 columns, that means it will be O of 9 into 9, O of 81. 81 cells we have to check. For each cell we check if there is not a value, that then skip it. If there is a value, that means for 5 we check if it is valid or not. That means 5, the row of 5, the column of 5, the row of 5, and the box of 5. For 3 we check the row of 3, the column of 3, and the box of 3. For empty cell we don't check anything, we continue 7. Similarly, okay, so for each cell we call a function, let's call it check, let's implement it later. So we do 5, let's say it is correct, so okay, proceed. 3, it is correct, proceed. Skip, check 7, proceed. Skip, then 6, check. Let's say we kept doing it, and then when we reach this element, after many times loops, this element, when we call this function, so we saw, let's say there was a 2 here, so we did the column check, the row check, it is fine, the box check, it is fine, but in the column check we saw that it is false. That means if 2 is here, that means this, the whole image, the whole set we got the input, it is not accurate because this is not solving the question, because it broke a rule. So then we stop here, because if we now know that the input is not wrong, we cannot get a valid Sudoku from this. So don't proceed from here, okay. So let me just erase it now because we got the logic. Now we will we see what this function, the check function, let me just erase it all. So we will take 0, 1, 2, 3, 4, 5, 6. We will take a part of the Sudoku grid, 5, 6. There are 3 elements or more, but we are not taking that because then the box will be too big. 1 2 3 4 1 2 3 4 5 3. Okay, so it's a 6 by 6 grid, but consider that this is complete, but we are not drawing that. So now let's say we got the input for this 4 here. So it is second row and first column, zero index zero indexing. Okay, zero base indexing. So now we have to check the full row and full column. That means full row and full column. We will do this one because it is easy. So it's simple. We know the row, we know the column. So to check the full row, we have to do what we have to do is I stays same and the j goes from 0 to 8, and we when I equal to 2 when j equal to 2, because this is the same cell, we continue, and for every other possibility, if there is any element that is equal to 4, that means this is false. So we check that. Similarly, we do for the same column. We loop I is equal to 0 to 8 and j says same because the column says 1 and the I is 0 1 1 1 2 1 3 1, column is same and the row keeps increasing, except the part 2 part, because we will just do if I equal to 2 continue, because when we are doing traversal, this is not equal. When we reach this element, this will be equal to this element because they are the same coordinates. So we skip that. So we did this also. Okay. So now we have the row check and the column check. Now the last check, that is the box check. How to do that? Okay, we have 2, 1. This is the coordinate for list. So we want the box, and we can be anywhere. We can be here. All these 9 cells should return the same box. So how to do that? So we have 2 1, but we want see, each box has fixed size 3 by 3. Even this box will have 3 by 3. Only the corners will change. The length and the breadth won't change. Only the corners will change. So if we can get any corner 1 2 3 or 4, using that corner we can just do any loop and get all 9 cells. So corners are the strongest cell, because but if we have this, we don't know we have to how many cells upward and how many cells downward. Let's say we have this, then 2 cells upward, we have this, then 1 cell upward. So it is very complex. So, but the corner cells are special. So let's say we can somehow get the corners, the top left corner of any cell, then we can just do 3 times loop here and 3 times loop here, so we get every cell. So from 2 to 1 we want to get 0, 0. So what can I see here? And there is a special number 3 because every cell is 3 size. So if we 2 is nothing but the remainder when we divide 3 by 2, sorry, when we divide 2 by 3, and 1 is the remainder when we divide 1 by 3. So if we can somehow do 2 minus 2 modulo 3 and 1 minus 1 modulo 3, that means from second row remove the remainder when we divide 2 by 3, so we get this row. So 2 minus 2 by 3 is 2 minus 2 equal to 0, 1 minus 1 modulo 3 equal to 1 minus 1 equal to 0. So we got this element. Now you might think it works to this, it might not work for any other element. So now try this one. The cell is first row and 6th column. Okay, no, actually it is 5th column, first row and 5th column, and what we want is this corner, that means 0th row and 3rd column. So we want 0, 3. So if we do 1 minus 1 modulo 3 and 5 minus 5 modulo 3, we get 1 minus 1 0, and for this we get 5 minus 2 equal to 3. So what we got is 0, 3, which is our corner. So using this logic, which is r minus r modulo 3, c minus c modulo 3, this coordinate will give us the top left corner of any cell. So now we have this also. Now we can just do the loop from here. We have the, let's call it x, y. This cell was ij, where we are right now, and the corner will be called x, y. So what we do is x, let's say a is equal to x, then a plus plus 3 times, and then in the second loop we do b equal to y and b plus plus 3 times. Now in this loop we get the 9 boxes of the cell, and except this cell we check each cell if it has the same value as this cell, and if it has, then we return false. So this was our solution. What we did was we first did the full traversal of the matrix of the full Sudoku. So that was O of 9 into 9, because there are 9 rows and 9 columns, and for each cell we call the check function. Check function, what does it do? It does checks 9 elements here, 9 elements here, and 9 elements here. 9 plus 9 and plus 9. That means O of 9 into 3, because 9, 9, 9 3 times. So that is almost equal to 9 into 9 into 9 into 3. So if it was n, we could have said n cube. But Sudoku game cannot be played in bigger bits. It's fixed that it will always be 9 into 9. So we can say that it is somehow in a constant time. So that was our solution. It was a proof of solution because we tried every possible scenario, and then we told if it is possible, if it is a valid Sudoku or not. So now if we want to optimize it further, first of all, this is a very good solution. It is O1 space, but yeah, we can see that. Let's say, let me just erase a bit. So let's say the element was here. Many elements, okay. An element is here. We check the row, the column, the row, and the box. And for this element, we check this box again. But we have already done. If there was some way to remember that we have already seen this much numbers in this box, that way we can further optimize it. Like, because these 1, 2, 3, 4, 5, 6, 7 elements are common for this check also and this check also. So why do we need to loop again? So to remember something, we obviously want something like hashing stuff. So that will be our HashSet, because HashSet can get us the get method is O1 of 1, because we can just get in constant time. We don't have to loop check 9 elements to get the element. So let me just make the box again. So let's say this is our matrix. I will not draw the boxes, but these are the rows and columns for the reference. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. To store the rows is simple. For each row, store a set, because we can store an array also, but for array we have to loop the array again. So it is same as this one. To get if there is 5 or not, we have to check every element if it is 5 or not. But with set, we can just get set dot contains 5, so it will just return as true or false in O of 1. So we will make a set for each row, so 9 sets, and 1 set for each column for 9 columns. And the first time the check is done, it will just store the values. But the next time, if we already have those values from the previously, so we will not solve them again. We will just use the set values. So these two were easy. But how do we get the boxes? Because again, the boxes logic is different. We have to get the right box for each one. So that means the 9 boxes. Let's name all the 9 boxes in the grid. It is 8 actually, 8. So the first box is 0, 1, 2, 0, 1, 2. Second box is 3, 4, 5, 3, 4, 5 and 0, 1, 2, and 3, 4, 5 and 3, 4, 5, and 3, 4, 5 and 6, 7, 8. Then again this one. So let's number them 1, 2, 3, 4, 5, 6. No, wait, we can number them as starting from 0, I guess. Let me check. Okay, you know what? Let's just name them as a number. So this will be 0, 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8. So for any row and column in this box, we want 0 as the answer. How do we get that? Okay, so there's a formula for that. That would be row by 3 into 3 plus column divided by 3. So let's try it out for this one, which is 1, 2. Again, let me just erase some stuff to get some space. So if we have 1, 2, what we will do is row divided by 3 into 3. You might think why we divide and multiply, but this one answer will give us 0, and then into 3 is equal to 0, and plus column divided by 3. That means column is 2 divided by 3 will give us 0, so 0 again. So that means this cell belongs to 0. Same will happen for this, and for this. Let's say we have cell as first row and fourth column. So we have first row, fourth column. We will do 1 divided by 3 into 3 plus 4 divided by 3. So it will be 0 into 3, 0 plus 1. That means 1 here. So similarly, we can try this for every cell. We will get the correct cell number for each one. So this way, we were able to do this by using 27 new sets. But this time we reduce the time, so we don't have to check each cell each time. So this will optimize the solution a lot. So that's it for today. Thanks for watching, and I'll see you next time.